Major avalanches can be regarded as randomly occurring events. They occur at a uniform average rate of 8 per year. Find the probability that more than 3 major avalanches occur in a 3-month period. Then, second part, find the probability that any 2 separate 4-month periods have a total of 7 major avalanches. Third part, find the probability that a total of fewer than 137 major avalanches occur in a 20-year period. In the first part, we were asked to find that more than 3 major avalanches occur in a 3-month period. So therefore, part A, or part 1, more than in a 3-month period. Now we know that the average rate is 8 per year. So that means 8 in 12 months. So in a 3-month period, that means we're going to have to divide by 4. So 2 in 3 months. 2 avalanches in 3 months. Therefore, we can define this as X follows a Poisson distribution with mean lambda 2. And now we're told that we need to find that there are more than 3 avalanches. So probability of X being greater than 3 is basically 1 minus the probability of X being, so we can say X being less or equal to 3. So we have 1 minus probability of 0, 1, 2, and then 3. Therefore, we're going to use probability of X is equal to R, which is equal to e to the minus lambda power R over R factorial. Now that's our formula from the Poisson distribution. And so what we're going to do now is minus e to the power of minus lambda, and then for power 0 it's always equal to 1, okay, plus, and then I've got lambda, that is 2 to the power of R, so 2 and then power 1 divided factorial of 1 plus 2 to the square over factorial of 2 plus 2 to the power of 3 over factorial of 3. And if you were to put all of that into your calculator, you should be able to get 1 minus, compute this, it's going to be equal to 0.857123 and so on. So basically we round this off to 0.143 after the subtraction. So this is the second part of the question. First part of the question. For the second part, we need to find that in a 2 months, 2 separate 4-month periods. So 2 separate 4-month periods. So what are we talking about is 4 months. So if we take 12 months, divide by 4, we're going to get so 4 months period, so 12 divided by 3, I would say we get 4 months, isn't it? Because 1 year is 12 months, so 4 months can be obtained by taking 12 divided by 3. In a similar way, we're going to take the 8 per year, so that's going to make it 8 over 3 avalanches. And because we're talking about 2 separate months period, so maybe we can say Y follows the Poisson distribution into 2 times 8 over 3. So basically we are saying Y follows the Poisson distribution with mean lambda 16 over 3. And now we need to find that the total is 7. So basically Y, probability of Y is equal to 7. Very easy, we're going to be using this again. So this is e to the power minus lambda, so that means e to the power minus 16 over 3 times 16 over 3 to the power of R, that is power 7 divided by 7 factorial. And if you were to work this on your calculator, you should be able to get 0.118. There we go. Second part of the question is done. And now for the third part, find the probability that the total of fewer than 137 major avalanches occur in a 20-year period. Now in 20 years, how many avalanches are expected? Because it's 8 per year, as you can see there. So for 20 years, it's going to be 20 times 8. So we are expecting 160 avalanches. Now that's a very big figure, therefore it follows a normal distribution. So we can define X being normally distributed with mean 168 and 160 and then 160 again for the variance. And because we want x, probability of x, so we have approximated here to a normal distribution. And of course, if you approximate to a normal distribution, you're bound to do the the continuity correction. So probability of x being less than 137 is going to be equal to probability of z being less than 136.5 minus the mean 168 over the square root of the variance. And let's do this from our calculator. We get p of z being less than minus 1.858. So basically what we're saying, this is phi of minus 1.858. And if you were to look at this from your normal distribution curve, okay, we're looking at something like this here. So this is 0, so less is going to be here, and then minus 1.858 is over here. So we can reflect this on the other side, and then 1 minus phi of 1.858. So what we're saying is 1 minus 0.9684. And so we end up with 0.0136. So now that's the answer to the question. Okay, take care. I hope that has been of some help to you.